Okay, guys, we are doing Algebra 2, section 3.2. For this section, we're going to solve quadratic equations with a power greater than 2. So, for example, we're going to have x to the 6th minus 11x, x to the 3rd, plus 18. And that equals 0. Notice this is not x squared and then just x and then the constant. This time we have x to the 6th and then x to the 3rd. And I will show you how to solve these. So the first thing you do is we're going to find a common x power. What do you mean by that? So we have an x to the 6th here, and we have an x to the 3rd. Can we use, we could try 2, but 2 won't go into 3. So 3 divided by 2 is not anything that we want to use. We could use 3. So 3 divided by 3 is 1. And 6 divided by 3 is 2. So we'll use that. And this is what we're going to do. We're going to say x cubed and then squared. Remember, when you have this, the way you solve it is you take the 3 and you multiply it by the 2. So 2 times 3 is 6. That's why we're getting the 6. So this is equal to this. Minus 11x to the, 11x cubed to the 1 power. So 3 times 1 is 3, just like this 3 here. So 3 times 2 is 6, just like this. And then we'll just write our constant down. So now let's let u equal x cubed. So we can rewrite this now. If we let this be true, we can rewrite this to u squared minus 11u plus 18 equals 0. Oh boy, this is supposed to be 0. Now this looks like something you can solve, right? So let's put our new solving techniques to the test. We have 18. We're going to write it down here. Let's find the factors of 18. So we know we have 1 plus or minus 1. Minus don't go that way. We know 2 will go into it. Now, well, 3. So we can take 18 divided by 3 on your calculator, and you will get 6. What else will go in 18? Well, 4. 5 won't. We know 6 will. We probably don't need any more factors than that, but let's see here. I don't think there's any other numbers except 18, perhaps. Perhaps 9, because 9 times 2 is 18, and then we'll just use 18. Now, we know this is a 1, right? So but we could do a 1 here, and we know that the factors of 1 are just 1, and this is just a positive 1. And we could do, what we're supposed to do. We're supposed to take these and put them over this, but that would be 1 over 1, 2 over 1, 6 over 1, 9 over 1, 18 over 1, which all of those are really just that number. So we're not going to go through that So if this is 1, you can just take the factors of the constant and you'll be fine. So let's build our little box here and put 1 on it. And our factors, our numbers here are 1. We have a negative 11. And we have 18. Let's see if this works. We'll drop down our 1. 1 times 1 is, well, 1. 11 plus 1 is negative 10. And 1 times 10, that's just negative 10. So that's not working. Let's try the next number up, which is 2. And we have our numbers again, which is negative 11 and then 18. And then we'll drop down our 1. So 2 times 1 is just 2. 11 plus 2 is negative 9. And 2 times negative 9 is negative 18. This does equal 0. So this is what we can do. We did this last chapter. We're talking about u now, not x, because u equals x third. We can say that u, okay, well, let me go back over this. This is u equals 2. Well, to reverse engineer this, we can say u minus 2 equals 0, which we would write this as u minus 2. And then we could use this for our coefficient, which is just u, and then this is our constant, minus 9. So we've solved this. Now, we'll set it to 0. Now we can say that u minus 2 equals 0, and then u minus 9 equals 0. And this is u equals 2. This is u equals 9. Now, remember we set this to u equals x to the third. So let's do that. U actually is x to the third. X to the third. So in order to break that, we have to say x is equal to the cube root of 2. X is equal to the cube root of 9. Okay. All right. So, hopefully you got all that down, and it's not that all difficult. Now, let's check our work. So how do you write this as something we can check our work as? Well, if you remember, we had this x to the 6, 11x to the third plus 18. That's what we need to check our work with, but we brought it down to this, which is x to the third squared, x to the 11 cubed to the first power. We're going to use this to check our work. And the way we'll do that is we know that x now is the square root or the cube root of 2. We can write this as 2. So we're checking this side, not this side. We can rewrite this as 2 to the 1/3 power. Right? Okay. To the 6. So we're actually not using this. We're using this one. Sorry, guys. This one right here to check our work as we should. Minus 11 2 to the 1/3 power cubed plus 18 equals 0. Now I'm all squished up. So this is how you solve this. Remember, when you have something in here, you must multiply it by the outside. So that's why we convert this to 1/3. So a cubed root can be 1/3. A fourth root can be 1/4. That's how we check these. So let's multiply. So 1/3 times 6 is what? Do we know? We can do it by hand. We can say 1/3 times 6/1 equals 6/3, which is actually just 2. So this would be 2 squared minus 11. Now we got 1/3 times 3/1, which is just 1. So we have 2 plus 18 equals 0. Now 2 squared is just 4 minus 22 plus 18. And if you get your handy dandy calculator out, you'll see that 4 minus 22 equals -18. And you add 18 to it, and you are 0. So 0 equals 0. So we checked our work, and it checks out good. Now, the 9 on this side, we would do the exact same way. So this is an example of how to check your work. It's easy to do. You just multiply the 2 by using the fraction of the cube or the square or the fourth root or fifth or sixth or whatever you got, and save time. Because this is not a very hard task, I will skip that part. All right, so let's look at another example and look at how we can solve an example such as this. So you knew this was coming back. Minus 3x over 1/4 minus 4 equals 0. Now don't be intimidated by the fractions above here. What we need to do is figure out what u is going to be, because we're going to substitute these for u so it's easier for us to process. Now we know this one needs to be squared, right? So the easiest thing to do here is, if you want this one to be squared, we can, well, let's do it on this side. So we can say 1/2 divided by 2, because we want it to be squared. We can say equal to 1/2 times 1/2 equals 1/4. So we have our number. We could put x to the 1/4 squared here. So let's just do that. X to the 1/4 squared minus 3. Now this is already to the 1/4. So let's do this. Let's x to the 1/4 to the first power minus 4 equals 0. So this is x to the 1/4 minus 3x1. So both of these are x to the 1/4 now. So let's say u equals x to the 1/4. And now we can rewrite this as x squared minus 3u minus 4 equals 0. Now let's put our little thing to use here. We have 1, we'll try 1, and we have 1 here, -3 here, and -4. Oh wait, we didn't get our factors. So factors of 4 are just 1, 2, plus or minus. That would be, okay, and then 4. So let's try 1, +1. Let's drop down the 1. 1 times 1 is just 1. And this is negative 2. And 1 times negative 2 is negative 2. This does not give me 0. All right, let's try something else. Let's try, I'll get rid of my factors. Oh, well. So let's try 2. 2, got 1, negative 3, negative 4. Drop down our 1. 2 times 1 is 2. So this gives us negative 1. And then 2 times negative 1 is negative 2. That didn't work out either, did it? Let's try negative 2. Okay, negative 2. Drop down our 1. Negative 2 times that is negative 2. And that gives us negative 5. Oh, nope, that ain't gonna work either. So maybe we should try negative 1 because we're not trying all of them. So let's try the 1, the negative 3, the negative 4. Drop this down. Negative 1 times negative 1 is and then we get negative 4. And this will be 4, and that'll be 0. Okay, so we found our 0, and it was a negative this time. That's why we write, when we do our factors, plus and minus 1, and plus and minus 2. Now, I didn't put these over anything because this is an understood 1. Now, let's solve this using what we've learned here. So I will show you here. U equals negative 1. Reverse engineering this, it would be U plus 1 equals 0. So this is U plus 1. And this is U, because this is 1 that goes right here. And this is minus 4, because this dropped down to there, equals 0. Now, we can solve this. U plus 1 equals 0, and U minus 4 equals 0. So this is U equals negative 1, and this is U equals 4. Now we substituted x to the 1/4. So we're going to need to check our work. Let's do that. Well, not check our work, but plug this in. So x to the 1/4 equals negative 1, and x to the 1/4 equals 4. Now, you're going to say, well, how do I solve this? Easy way to think of this is x to the 1/4, right? You could do this basically equals x equals 4 times 4 times 4 times 4, which is 256. This is okay. So to solve this right here, you're saying you're doing this right here. Oh, I'm sorry. No, you're not. Oh, good grief. You're raising this to the 4th power. So to undo this, you're basically doing this, and then you're doing this on this side, which is why it's 4 times 4 times 4 times 4, because this cancels out, because 4 over 1, and that's just 1 now, and then 4 to the 4th power, and that gives you 256. This side is basically just x equals negative 1 times negative 1 times negative 1 times negative 1. Negative 1 times negative 1 is 1 times negative 1 is -1, and then -1 times -1 is just, well, 1. Playing with negatives. That's so fun. All right, now to check our work. How do we check our work? Well, we grab our original equation, x1/2 minus 3x1/4. So we know that x, it could be 1 or it could be 256. Let's just play with the 256 part. Seems more fun. 256, 256. And that is 1/2 minus 3x 1/4. Uh-oh, not x. I am substituting x. 256 to the 1/4 power minus 4 equals 0. That's the test. So how would you solve this? Well, 1/2. So you're writing it like this. So, let me just do this. 256 to the 1/2 power is equivalent to the square root of 256. Okay, you can do that in a calculator. I think that's 16. So 16 minus, now 3 times 256 to the 1/4 power is basically this right here. You can do that in a calculator. So if you plug that into your calculator, you'll get 4. So that's 3 times 4 here. Minus 4 equals 0. All right. So now we have 16 minus 3 times 4, 12, minus 4 equal to 0. And that will become, from our handy dandy calculator, 16 minus 12 minus 4 equals 0. So this is just 0 equals 0. It checks out. And that's how you check those. So if it has a power to a fraction, you're just doing the square root or cube root or 4th root of that number. All right, let's look at another one with the fractional exponents. X 2/3, or notice this doesn't, it's not a 1/3 or a 1/4, it's a 2/3. That shouldn't deter us from solving it the exact same way. It's just a different way to, it just looks different. Minus 6 equals 0. Now, the way to solve this is exactly the same way. We know we want this to be squared. So we take 2/3 and divide it by 2. And we know when we divide, we flip that last fraction. And this gives us 1/3 because these 2's cancel out and you're left with 1/3. So now we can say this x 1/3 squared, and those 2 are equivalent. Now we already have one x 1/3 here, so we're going to say 5x 1/3 to the 1st power. And that will allow us to substitute x 1/3 in as u. So now we're left with u squared minus 5 u minus 6 equals 0. Something we can solve. Let's go ahead and solve this. We have a 1 here, so let's do our factors of 6, which is plus or minus 1, plus or minus 2, and plus or minus 3, and plus or minus 6. Okay. Now, let's draw our little box. Use the first number. We have 1, -5, and -6. 1, bring the 1 down. 1 times 1 is just 1. -5 plus 1 is -4. And -4 times 6 is what? You don't know. All right, so we're looking at 4 times 6 is 24, so we're at positive 24. That is not 0. Let's try something else. About 2. Just going to get an eraser and do this. There. 2. 2 times, oh, let's bring our 1 down. 2 times 1 is 2. -5 minus 2 is -3. And 2 times -3 is -6. This is -12. Looks like we need to reverse our sign here. So let's reverse our sign. -2 times this 1 is negative. It's -7. Does it make sense? Let's try it again. 2 times 1 is 2. This gives us -3. And this gives us oh, it gives us -6. It does give us -6. -6 plus -6 is -12. That won't work. Well, let's keep going. Looks close, but just didn't work. So let's keep going. Sometimes you have to. Let's try 3. 3 times 3 is 9. This is like 4, and 3 times 4 is 12. That ain't working. All right. Let's try 6. Bring down 1. 6 times 1 is 6. This is 1. 6 times 1 is 6. Oh, there's 0 right there. We found it. So it's actually the 6 this time, instead of being the 1 or the 2. So let's rewrite this. We know that this 6 is u equals 6. If we reverse engineer that, that's u minus 6 equals 0. And we can just write u minus 6 as one of the solutions. And then we can write also that this 1 is in front of this u right here. And this one is just that one right there. And that's our solution. Well, close to it. Now we can say that u equals 6 and u equals -1. Hopefully you know how I got those. We've been doing that. We've been skipping that step for a little while, so I think you guys will be good there. Now, check our work. It can be a little intimidating because we have a 2/3. The first thing we need to do is take the u substitution and put it back. So it's x to 1/3. So this would be x over 1/3 equals 6. And x over 1, not x over 1, x to the 1/3 equals -1. So this one, x would actually equal 216. Because remember, to solve this, this would be x equals 6 times 6 times 6. If you do that on your calculator, 6 times 6 times 6 is 216. So on this one, do it out here. X equals -1 times -1 times -1, which is just -1 times -1 is 1, and 1 times -1 is -1. So this is actually equals just -1. Okay, so we found our X values. We just need to check our work. So we'll be using this original equation here, X to the 2/3. So we want to say 216 to the 2/3 minus 5 times 216 again to the 1/3 a minus 6 equals 0. So I'm not solving for this one, I'm actually solving for this one right here. So the way you solve this 2/3 here, we don't have a 3. This 3 represents the cube root. This one's the cube root. It's just the root, I guess I should say. And this is the power. Try to write this best I can. Oh, okay. Not Palmer, but power. So the way we do this is 216. Let's just do it down this line right here, and then we'll fill in the blanks. But 216. First thing we're going to do is take the root. So we'll do the root of the cube root of 216. You can do that on your calculator. The cube root is actually 6. And I know that because we powered it by 6 here to get 216. Now we're breaking it back down. Then you take the power and you do it there. So 6 squared is basically like 6 times 6, which is 36. Oh, sorry. Yeah, 36. So this number actually becomes 36 minus 5 times. Now we said that 216 cubed is 6. So that's what we're writing. And I got that cubed from here. That's the root. Remember, the root's the bottom one. Minus 6 equals 0. And to continue this one, 36 minus 5 times 6. And then minus 6. Okay, so then we'll just say 36 minus 30 and minus 6 equals 30. Now, what did I get wrong here? Did I do my math right? Let's try it again. 36 minus 30. Oh, wait a minute now. 36 minus 30 equals 6. Okay. And then 6 minus 6 is 0. So yeah, I didn't even use the calculator right. There we go. So it checks out for that half anyway. The other half you guys can figure out that it's just -1. So it's much easier to get the root and the power of 1. Okay. All right. All right. So there's another small section that we need to look at, and it has to do with these fractions. I think I may have already covered this, but we're going to go over this section here. So we need to find the solutions for x plus 2 to the 2/3 power equals 16. Remember, I said the bottom here is the root and the top is the power. So the easiest way to look at this would be, how do you get rid of a power of 2? So how would, if this was like just x plus 2 squared equals 16, how would you get rid of that? You would square root both sides, right? Oh, that's what we're going to do. Let's square root both sides. And that ends up with, that cancels this 2 here. So we're left with x plus 2, 1/3 equals the square root of 16, which is plus or minus 4. Now, there's another way to think about this, or another way to do it, and I think we did this too. You can say that 2/3, we're going to square it, right? Times 1/2 equals 1/3, which is where this 1/3 came from. So you could just think of it like we've been doing it, but this top number might not be a 2. It could be a 3 or a 4. So this way would be the absolute way you could do it. Just 2/3 times the whatever you want to pull off, which will be this top number, the power. And you're left with the root. This is the root here. Now, how do we solve this? So just, this is the root. So we can always take a root off by raising it to a power. So we could say x plus 2, 1/3, and to put all this over a power of 3. And I'm getting ahead of myself. I'm doing all right. This is plus or minus 4 to the power of 3. That's one way to think about it. And this would just end up being x plus 2 equals plus or minus 64. Or you could think about it differently. This canceling out the power here, all we did was 1/3 times 3 over 1. And that's just 1. So that's how we canceled this out. Okay. So, and then to solve for this guy, you would say that x equals, because we're -2 and this and over, -2. It would be -2 plus or minus 64. And because it's plus or minus, you could say that 2x equals -66 and 62. Because -2 minus 64 is -66, and -2 plus 64 is 62. So that's my 2 solutions for x. Okay. So for homework, let's do, let me look at all the homework. Okay. Yep. Let's do teal, odd. Okay, so 3.2, which is on page 133. Do 1 through 37. 37, teal, odd. I should just give you all the ones on the left-hand side. to solve. Just put into practice what we've learned today and the last chapter. I think you should be good. All right. Thanks.